In mathematics and especially in combinatorics, a plane partition is a two-dimensional array of non-negative integers that is non-increasing in both indices, that is, that satisfies for all I and j, and for which only finitely many of the ni, j are non-zero. A plane partitions may be represented visually by the placement of a stack of unit cubes above the point in the plane, giving a three-dimensional solid like the one shown at right. The sum of a plane partition is and place denotes the number of plane partitions with sum n. For example, there are 6 plane partitions with sum 3, so place equals 6. Ferrers diagrams for plane partitions. Another representation for plane partitions is in the form of Ferrers diagrams. The Ferrers diagram of a plane partition is a collection of points or nodes, with satisfying the condition fd. If the node, then so do all the nodes with for all. Replacing every node of a plane partition by a unit cube with edges aligned with the axes leads to the stack of cubes representation for the plane partition. Equivalence of the two representations given a Ferrers diagram. 1 constructs the plane partition as follows. Let be the number of nodes in the Ferrers diagram with coordinates of the form where denotes an arbitrary value. The collection form a plane partition. 1 can verify that condition fd implies that the conditions for a plane partition are satisfied. Given a set of that form a plane partition, 1 obtains the corresponding Ferrers diagram as follows. Start with the Ferrers diagram with no nodes. For every non-zero, add nodes of the form for to the Ferrers diagram. By construction, it is easy to see that condition fd is satisfied. For instance, below we show the two representations of a plane partitions of 5. Above, every node of the Ferrers diagram is written as a column and we have only written the non-vanishing as is conventional. Action of S3 on plane partitions. There is a natural action of the permutation group on a Ferrers diagram. This corresponds to simultaneously permuting the 3 coordinates of all nodes. This generalizes the conjugation operation for partitions. The action of can generate new plane partitions starting from a given plane partition. Below we show 6 plane partitions of 4 that are generated by the action. Only the exchange of the first 2 coordinates is manifest in the representation given below. Generating function. By a result of Percy-McMahon, the generating function for place is given by this is sometimes referred to as the McMahon function. This formula may be viewed as the two-dimensional analog of Euler's product formula for the number of integer partitions of n. There is no analogous formula known for partitions in higher dimensions. McMahon formula. Denote by the number of plane partitions that fit into box, that is, the number of plane partitions for which ni, j, c and ni, j equals 0 whenever I greater than a or j greater than b. In the planar case, we obtain the binomial coefficients. McMahon formula is the multiplicative formula for general values of. This formula was obtained by Percy-McMahon and was later rewritten in this form by Ian MacDonald. Asymptotics of plane partitions. The asymptotics of plane partitions was worked out by E. M. Wright. 1 has, for large, where we have corrected for the typographical error pointed out by Mutafchev and Kamenov. Evaluating numerically, 1 finds symmetries. Plane partitions may be classified according to various symmetries. When viewed as a two-dimensional array of integers, there is the natural symmetry of conjugation or transpose that corresponds to switching the indices I and j. For example, the two plane partitions and a conjugate. When viewed as three-dimensional arrays of blocks, however, more symmetries become evident. Any permutation of the axes corresponds to a reflection or rotation of the plane partition. A plane partition that is invariant under all of these symmetries is called totally symmetric. An additional symmetry is complementation. Given a plane partition inside an box, The complement is simply the result of removing the boxes of the plane partition from the box and re-indexing appropriately. Totally symmetric plane partitions that are equal to their own complements are known as totally symmetric self-complementary plane partitions. They are known to be equinumerous with alternating sign matrices and so with numerous other combinatorial objects.